Hello, I'm Sneha, and together with Peter, Lim, and Leilani Battle, we worked on a survey to understand the tools and techniques developed for database query debugging and recorded the experience of real users while they performed query debugging. Before I go on to introduce our contributions of this research, let me provide you with some motivation about why we should care about database query debugging. It is estimated that every second a single person generates 1.7 megabytes of data. With the current number of internet users, this results to about 2.5 quintillion bytes of data, big data every day. To extract information from this enormous complex data, it needs to be stored and processed. Database management systems like PostgreSQL systematically allows to create, retrieve, update, and manage such data. Database management systems enable users to specify their desired data by issuing queries on the datasets. However, in process to retrieve the appropriate desired data, users need to be able to write perfect errorless queries for which they need to debug their queries. Debugging queries is more than just fixing syntactical errors. Complicated errors like zero results or duplicate entries are thrown by the database management systems. In order to deal with such errors, the users need to have an intuitive understanding of both the structure of the queries as well as the database management systems. Now that you are aware of why we should care about database query debugging and the challenges it faces, let me inform you of our contributions. We wanted to study the works done in order to alleviate database query debugging and know how real database users are benefited from these techniques. In our research, we first performed a literature review across multiple research areas of databases, visualization, and HCI to find a shocking lack of work on debugging of complex database queries. Second, to better understand how the techniques in literature are used by the database users in the real world, we conducted a user study. We found that participants rarely use debugging proposed techniques in the literature and had hardly heard of any database debugging tools. Further, we reached out to six database tool designers to understand the industry perspective on query debugging and found that the industry is aware of database query debugging to be an issue but has other pressing needs like solving issues of query optimization. For the sake of time, I will be talking about only our findings of the literature review and user study. For surprising findings on the database tool designers, please read our paper. Let me walk you through the literature review. We selected our review papers from across multiple research areas such as databases, visualization, and HCI, as work of query debugging spans over all of these areas. Our selection process was framed around the review topic of algorithms, interfaces, and tools designed to support the debugging of database queries. Other related works were found to be targeted by searching on related topics like understanding query behavior, understanding user debugging behavior, query visualizing queries, etc. We reviewed a total of 112 papers of the past 25 years to understand strategies that users employ to reason about and debug queries. The first takeaway of our literature review was that even though research across databases, visualization, and HCI touches on how users interact with and analyze queries, it does not consider the challenge of debugging complex SQL queries. Moreover, we saw a dearth of information about users' database debugging strategies and tools across the three research areas. In another finding, we see that query debugging features seem to be more effective if adopted from multiple research areas. For example, visualizations of program behavior, intuitive interaction widgets, and effective database debugging strategies. Further, we observed that even though proposed debugging techniques have been around for over a decade, none of them exist in the current commercial debugging tools, suggesting that there is a wide gap between literature and existing commercial debugging tools. Apart from the works specific to debugging database queries, we found a lot of other works not performing SQL debugging but being tangentially related to SQL debugging. For example, there have been numerous interview studies to understand data analysis process of analysts, long-term projects logging queries issued by users, written or spoken and visual alternatives to SQL altogether, or data cleaning techniques. All of these may make querying simpler for the user but does not improvise users' querying or help the user debug their queries per se. We categorize works specific to database query debugging in 4 categories. First, we perform logical analysis where only the structure of the query is analyzed without executing the query. Second, performing the execution analysis of the query to know the intermediate results of the parts of the query. Third, performing both logical and execution analysis. And lastly, the commercial debugging tools we know of. QueryWiz is an example of the logical analysis category where nodes and link diagrams are used to demonstrate relationships between operators. Even though such techniques can be shown can show the structure of the query to the user, they cannot be used if the user wants to get a deeper understanding on how query affects the underlying data. Executing the query allows to view the provenance of the query and in turn be able to see the intermediate results in the form of provenance graphs. An observation though was that database provenance, unlike analytical provenance, focuses on history and source of the program results and not on the user's interactions and annotations. The third and most promising strategy of analyzing queries used both the logical and execution structure of the erroneous queries. These techniques aim to answer both the why and why not questions of the query. That is, why a certain record is seen in the results of the query and why a certain record is not seen in the result. These techniques provide the user with partial provenance information but poses implementation challenges, making it difficult for commercial adoption. Lastly, we came across many commercial database debugging tools. Though all of them focused on debugging the queries for the optimization and performance perspective and hardly helped the user debug their own queries. Furthermore, none of the tools seem to implement the state of the art in query or program debugging research. To better understand how techniques and literature translated into real world, we conducted interviews with 20 database users ranging from students taking database courses to full-time industry analysts. We asked these database users to first share the debugging strategies and tools they used on a daily basis. Second, we asked them to inform us of database debuggers they knew of, how they used them, or any other techniques they used to verify their results and be confident of their queries. Then we wanted to know about the strengths and weaknesses of the database debugging tools and techniques they have been using. Lastly, we asked the participants to share examples of visual aids they used to perform debugging and how these visual aids had benefited them. The first takeaway from the user study was that regardless of the ton of research across multiple areas and many commercial database debugging tools developed, 95% participants performed debugging of queries manually by hand. Moreover, 17 out of 20 participants were unaware of any kind of database debuggers or formal debugging strategies. Of the 3 participants who were aware of database debuggers, only 1 participant actually used it. This participant, who was also an expert, additionally expressed that the debugger was very daunting for her. Further, we observed that all 20 participants used the nested debugging strategy. In this technique, participants break a complex query into simpler SQL subqueries and debug the simplest component first. Once the first component results are as expected by the user, then the user debugs the next simpler component and so on. As quoted by a participant, this technique is also used to perform unit testing in form of small targeted inputs. For example, consider this query where the user wants to view the names of all items whose quantity is greater than 100. Participants would tend to simplify the query into simpler steps as shown and perform the debugging of each of these. Let me walk you through an example of the nested debugging strategy. In the first step, participants broke the main query into 2 simpler ones and performed the second inner query first to see its result. They first viewed all the product IDs and quantities in the order item table to have an estimate of the number of rows they should expect in the result, and then filtered the table having quantities more than 100. Once the participants were sure about the results of the inner subquery, then they focused on the IDs in this intermediate result. Then they performed the complete query to gauge what they saw similar IDs, whether they saw similar IDs in the final result. Finally, they got the needed product names. This nested debugging strategy was seen in the provenance-based debugging strategies in literature, pointing that there is an alignment of techniques used by real users and the solutions proposed in literature. Although these techniques are not adopted in commercial tools, or if they are, the users are not using them. Another observation made was that 15 out of 20 participants used some form of visual aids while performing debugging and shared that visual aids would benefit them largely to fasten their process. Examples of visual aids that participants pointed to were flowcharts to simplify their nested debugging as seen here, or having annotations on the queries to view the database schema. These are very simple features and can be incorporated into current tools. Also, a participant who used sophisticated database management systems did mention that the system had some features of visualizing data such as bar charts, but it only visualized up to 10,000 rows of data, which was not very helpful. On the basis of our findings of literature review and the study with database users, we suggest some design recommendations for improving debugging tools in the future. First, we suggest a new debugging tool to be built such that they can be integrated into existing tools like command line tools or database management system IDEs. Also, all of the commercial tools mentioned by our participants of the user study are very similar, and hence it will be easier to establish collaboration in the industry to develop integrated tools that support multiple database management systems. From our user study, we also found that participants stressed on lack of training to use these debugging tools. Our second recommendation focuses on developing educational models to fill this gap. An example feature that can be incorporated is hover-triggered pop-ups to explain database-specific terms when user interacts with the queries. A third recommendation we emphasize is to have users have the tools built with automatic features that support the nested debugging strategy that we observed across all of our 20 participants. Many participants hand drew simple visual aids as part of this nested debugging approach, and such visualizations can be prioritized as a starting point for improving the query debugging features. Further, annotation features like highlighting text notes or writing them could help users track the query components that they have already tested. Another possible annotation could be the ability to view the schema of the table in order to view the metadata immediately and reduce the cognitive burden of remembering details for the user. In summary, database management systems are important to manage and process large complex data sets to gain valuable information. The primary way to converse with these database management systems is to issue queries, and we find that even the expert users struggle to make sense of and debug these queries. To understand how the issue of query debugging is approached in the research community, we performed a literature review of works across three database communities: databases, visualization, and HCI. Having found very little work specifically on user query debugging, we conducted a user study with 20 database users to observe how users debug their queries, and saw a very high dependence on informal, self-learned debugging strategies. Lastly, to better understand the industry perspective, we reached out to 6 database tool designers. Finally, our major takeaway from our research is that we found all participants, whether experts or new to SQL, to all favor the simple nested query debugging strategy. However, the existing literature and commercial tools seem oblivious to this nested debugging, leading to users learning their own debugging techniques informally. Moreover, as no debugging techniques are taught in schools or workplaces, we also see a lack of infrastructure to learn how to debug queries effectively. Thank you.